Welcome to my YouTube channel. Hope you had a nice time. Today we'll be looking into forces. In my previous video we talked more about vectors, how to add vectors together, explanation of what parallelogram law of vectors and the polygon laws of what vector. Today we'll be looking at force. Outside a force, take for instance, if I hit this stupid guy that is there, whoa, it's move in different directions. Sorry, it's a stupid guy. Now if I hit it like this, it's move along one direction like this, it's come back. Depends on the kind of amount of, that means the movements of the body depends on the amount, or let me say the magnitude of the force given to the body to make it to go move to one direction. Then what is that force? A force, we said a force is a pull or a push acting on a body. He said, you see, a force can be a pull. How do you get the pull? For example, I tie something like a knot to this place here. Let me say I have a rope that is tied at this point here. Now, you see, if I'm exerting a force to pull the rope outward, you see, it's a force. This is a force. I can pull this rope outward to move a body. Or let me say I have a body that can easily slide on the floor. So if I exert a force to move this body along this direction, let me say force P. Now, this is a pull. A pull simply means to make it or to draw the body from one point to leave what, from one position to what, another. Now, we can also have what, a push that will be acting on the body. A push simply means exerting a force directly on the body to push it from its rest position. Are we together? Now, that is what the definition of what, of a force. You see, force is a vector quantity. Simply means, as you ought to understand that what forces has magnitude and direction. Now, note something that forces can be characterized by three things. There are three things that is used to characterize what force. One of the three things. Number one, we have points of application. Points of application of the force. Simply means every force must have its own point of application. Number two is the point of application, that's number one. Number two is the magnitude of the force. Magnitude of the force. Then number three is the what? Is the direction of the force. Now, note something I said, forces can be characterized by these three things. The point of application, the magnitude of the force, the direction of the force. What do you understand by point of application? Let's take a look at the board directly into me. Please, I'm sorry. Now, if I exert a force on this position of this board like this, in perpendicular direction to this direction of the board, you know, if you check here, the only point where my force is applicable is along this point here. I have the whole area of the board, but my force is only applicable to this point alone. These are called points of application of the force. See, we also have what called the magnitude. You see, the magnitude of the force is what characterized by the units of the force. What is the magnitude telling us about? It's just talking about the units that it depends. The magnitude of the force depends on the units of the what force. You know, we might have a larger unit, I might have a smaller unit. Take for instance, we have to understand that what forces are measured in Newton, but we can have a smaller unit that are even smaller than what unit. You see, the magnitude of the force depends on the unit that is given to it. For example, if I give a force as what millinewton, that is a smaller force. It's very, very small. Millinewton, or I'm giving a force of nanonewton. Nanonewton is very, very small. That means the force that is acting on the body is too small. Take for example, if I can assume that the force acting between particles of gases, or let me say the molecules of gases, is of nanonewton. Simply means the force is tiny or small that we can easily neglect the force in molecules of gas. Now, take a look. We can have a meganewton. Meganewton is simply 10 raised to power 6 of a newton, unlike the millinewton that is 10 raised to power minus 3 of Newton. Nanonewton is 10 raised to power minus 9 of Newton. You can also have kilonewton. Now, this kilonewton is 10 raised to power 3 of Newton. You see, the meganewton, the kilonewton, they are larger units of force. Normally, the main unit of force is what? Newton. You grab what I'm saying? Now, the main unit is Newton, but we can add a larger unit and a smaller unit of force. You grab, that's what we call magnitude. As for instance, a force of 6 meganewton is greater than a force of 20 kilonewton. That is the magnitude. So we have what? So the magnitude of forces varies, depends on the what? How large the force is. Now, we also have what? Direction. You see, direction can be classified, or let me say, the direction of a force is characterized by two things. What are the two things that can use to what? Explain the direction of force? Number one is the line of action of the force. Line of action of the force. That is number one. Number two is the sense of the what? Sense of action of the force. We have the line of action of force and the sense of what? The force. Now, what do we understand by line of action? Every force must have what? A single line at which it is acting. Now, a line of action is an infinite, let me say, line of action of force is an infinite straight line drawn through the axis of the force. The infinite straight line drawn through the axis of the force, we call it what? The line of action of the force. If you take a look at this thing very well, if I have this can represent what? A line of action. Please, before I forgot, you see, line of action of a force can be determined by what? The angle it's made with a fixed axis. Let me assume I have what? An horizontal fixed axis. If this is an horizontal fixed axis, now this line of action, this is the line of action, a force can act on this line of action. That means it can act. It's not compulsory that it must be the whole line of the action. Just let me say I have a force that is acting along this line, force F1. I can have another force that is acting along this line, force F2. These are two different forces that are having the same line of action. Meanwhile, you can also have a force that has its own line of action along this direction. This is a force F3. Now, this is another line of action. Now, this is another line of action. If I have line of action L1 and this one is L2, each of this line of action of a force make an angle with a fixed axis. Let's say that this angle is directed here. Why this one make an angle with this place here? You see the angle that is made by the line of action signify the direction of that force. It signifies what? The direction at which the force is moving. Now, what about the sense? The sense is simply what? Represented by the what? Arrow edge of the force. Sometimes two forces, if you check this force F1 and force F2, you try to look at what? You notice that they are on the same line of action. You grab, but their sense is different. Where their sense simply means their direction is different. This one is moving towards this direction, while this is moving towards what? This direction. So forces are classified using these three methods. In these three things, that means the point of application where it is acting, and the second thing is what? The magnitude, which is the size of the what? Vector. And I said the size of the vector depends on what? The unit. As in the unit. Either we are making use of a multiple unit or a what? A sub-multiple unit or a normal unit. Determines the magnitude of the force. Also, we talk about the direction, that the direction of the force is characterized by what? The line of action of the force. That means every force must have what? A single line of action and a sense of action. The sense simply shows us about the what? The direction at which the force is acting. While the what? Line of action explains to us about at what point, or let me say on which axis is the what? Force moving. Thank you very much. Thank you for watching my video. Please don't forget to subscribe to my YouTube channel, and so please click on the notification bell to receive my new video. Thank you.